Hello everyone, I'm a 4.0 pre-med and one thing about me is I study smarter, not harder. Today I'm going to be talking about carbocation rearrangement. Specifically, I'm going to be talking about hydride shift and methyl shift. So a hydride shift is when a hydrogen will shift over, and a methyl shift is methyl, obviously, right? So a methyl is going to shift over. I want to kind of give a side story. So I posted a video about hydrohalogenation, and a student told me like, hey, wait, this is not right. And I was like, why? And then he showed me his molecule, which is this molecule, and was like, why? I followed your steps from your video of hydrohalogenation, and this is not what I got. And I want to tell you guys, it's not that my mechanism was wrong, because my mechanism was correct for the molecule that I did it for, which is why I'm making this video, to explain to y'all, in case your professor didn't tell you when you're learning the class by yourself, like I know some of you are, you can have a hydride shift, you can have a methyl shift. What happens is that the molecule is going to want the chlorine or the halogen or whatever, it is going to look for a better place per se. So if you have let's jump over, give me 1 second, and then I'll go back to the other point that I was making. So you can have primary, secondary, tertiary, and allylic carbocations. Primary are the least stable, and they're the worst, okay? And then tertiary, well, technically allylic is the most stable, and then tertiary. So in this molecule, when you do the hydrohalogenation reaction that I showed you in my last video, which I still recommend you to watch that because most of them are going to follow that normal pathway, what happens is that in this particular molecule, you're going to have a hydride shift. And I'm keep saying that, so let's get into the actual mechanism. So first, the electrons are going to go and grab that hydrogen. Remember, electrons are really electronegative. Hydrogen is more electropositive. Then that bond between hydrogen and chlorine, those electrons are going to go over to the chlorine. Okay, so far so good. Regular hydrohalogenation reaction mechanism. Hydrogen goes with the homies, like I have in yellow, which I told you guys before. And then you form your carbocation. So you would naturally think that chlorine is going to attach there. No, that's not what happens. In this molecule, again, watch that other video because most are going to go with the mechanism I showed you in the other video. In this specific molecule, you're forming a secondary carbocation. You're attached to 2 carbons, 2 R groups. So the hydrogen shifts over, and then you form a tertiary carbocation. That's 3 R groups. And then the chlorine goes and attaches. So one more time. The electrons go and attack the hydrogen. The bond between the hydrogen and the chlorine goes to the chlorine. The chlorine gets those electrons and becomes negative. And then, because of the formal charge again, and then you have this carbon that's attached to 2 carbons. So it's a secondary. If you're still confused, the primary, secondary, tertiary, I have a video on that about carbocations, so go watch that. Okay, so in this molecule, you have a secondary carbocation, and then the hydrogen will shift over, and then here you have a tertiary carbocation. This carbon is attached to 1, 2, 3 carbons. So you have an even more stable carbocation, and then the chlorine is negative because of the formal charge, because it grabbed those electrons from that from the hydrogen, goes and attacks that tertiary carbocation and attaches. And again, in this molecule, I'm not drawing any enantiomers because you have 2 methyl groups here, so it's achiral because you have the same group. For it to be chiral, you need 4 different groups. If you're still confused about chirality, I have a video on that as well. So this molecule is not chiral. So you're not drawing any stereochemistry, and that's why, because I have students asking me why sometimes you draw stereochemistry and why sometimes you don't, and it has to do with the chirality of the molecule. Okay, so far so good. And if not, please rewatch the video to get it. So the same thing can happen with methyls. Methyl groups can also shift over, just like the hydrogen. And again, it's to have that more stable carbocation. So let's use the same molecule. I'm going to use exact same molecule. See? And as you can see, you have a methyl group now, which I changed. And again, same process, double bond goes and attacks the hydrogen. Those bonds are going to go to the chlorine. You form your secondary carbocation. And then the methyl group is going to go and shift over. And then you're going to have, again, a tertiary, and then chlorine is going to attach. And I redrew the molecule with the chlorine right here, just for you guys to see the difference. Oh, see, I even have it from last time. So this would be the CH3. So again, it's the same process. You're going from a secondary, you have a methyl shift or a hydride shift to form the tertiary, and then the chlorine goes and attaches. So if you like this video, if you like my explanation, please comment, like, share, follow, and please send it to other students, because my goal of making Sci for students was to help you guys, to help all of you, and to help you all succeed, and to show you my knowledge that I've gained from taking these classes, and hopefully help make the journey a little easier for all of you. So thanks again for watching, and happy studying.